New chapter, differential equation. And this is the last chapter of integral. The name of the chapter is differential equation. Now, see, what is differential? What is differential equation? We know an algebraic equation. The algebraic equation is, say, x square minus 5x plus 6 equal to 0. This is an algebraic equation or a quadratic equation. Like this one, we can write sin square theta plus 2 sin theta plus 3 equal to 0. This is what? This is a trigonometric equation. Similarly, if an equation contained differentials, we call this as differential equation. Say dy dx plus y equal to 6. This is what equation? This we call differential equation. Similarly, say d2y dx square plus dy dx plus 7 equal to 0. This is also a differential equation. Now, there are two things of a differential equation. One is order and another is degree. Now, what is order? What is degree? Now, say if I write d2y dx square whole thing to the power 5 plus dy dx whole thing to the power 100 plus 7y equal to, say, 6. Now, this is a differential equation. Now, I have done differentiation here. I have done differentiation 2 times. So, highest number of differentiation is nothing but order. Highest, you can say differential or differentiation. Differentiation. So, here highest differentiation is what? 2. So, order will be equal to what? 2. The power of that highest differential equation, or highest differentiation, power of that highest differentiation is nothing but degree. That means here, see, I have written here 100, but this will be not the degree. Degree will be highest differentiation to its power. So power is what? 5. But provided the differential equation does not contain any say indices of rational number or negative. For example, say if I write dy dx equal to d2y dx square equal to dy dx plus 7. This power of dy dx is half, so we can write the order, but we cannot write degree. For that one, what we have to do? First, we have to remove this root. How to remove? d2y dx square minus 7 equal to dy dx whole root. Now squaring both sides. So d2y dx square minus 7 whole square equal to dy dx. Now, if I break this one, it will become what? d2y dx square whole square minus 7 d2y dx square, not 7 to the what? 14 plus 49 equal to dy dx. Now it is clear. Order is equal to what? Order equal to 2 and degree equal to what? Degree is also equal to 2. Order is also 2, degree is also equal to 2. So this is nothing but order and degree of a differential equation. So say question number 1. dy dx whole thing to the power 4 plus 3 d2y dx square equal to 0. Write order and degree. So order will be equal to here. Order will be equal to what? 2. Order equal to what? Order equal to 2 because highest differentiation is 2. So order equal to 2. And degree equal to what? The power of that highest differential equation. So degree equal to what? Degree equal to 1. Okay. Now say dy dx number 2. Say dy dx plus sine dy dx plus sine dy dx equal to 0. dy dx plus sine dy dx equal to 0. This one we have order but we don't have. Order is 1 but degree not applicable or not defined. Degree since it is inside a trigonometric function, degree not applicable or undefined. Okay. Next, number 3. Number 3, 1 minus dy dx, 1 minus dy dx whole square, whole root equal to a d2y dx square whole thing to the power 1 by 3. Now we cannot do directly. First you have to remove this root. So it will be 1 minus dy dx, 1 minus dy dx whole square equal to a d2y dx square with. Now this is also 1 by 3. So you have to remove this one also. So we will multiply throughout by 6. We will multiply throughout by, this is 3, this is half. So throughout power by 6. Not multiply. We will give power 6 both sides. So if I give power 6, so this is 2. So this whole will become what? Whole will become 3. 6. So this will be whole will become what? 2. Now, you can break this one, but don't it here, because your highest differentiation is what? 2. Highest differentiation is 2, and degree is also what? Degree is also equal to 2. Degree is also equal to 2. Power of highest differentiation, this immaterial now. Okay, understood? Now, how to form a differential equation, or formation of a differential equation. Formation of a differential equation means you have to form a differential equation. An algebraic equation will be given to you, and you have to form a differential equation. Okay. Now, how to form a differential equation where an algebraic equation is given to us. Say, number 1, y equal to a cos x minus b sin x. Form differential equation from this equation. Form a differential equation. Y equal to a cos x plus b sin x. Y equal to a cos x plus b sin x. Now, how to form this one? Now, this equation contain two constant. This picture is not clear. 1 minute. This equation, yes, knocking down is clear, contain two constant. One is a, another one is b. One is a, another one is b. This constant we call arbitrary constant or any constant. This constant we call arbitrary constant or any constant. Say y equal to x plus c. Now, in this case, y equal to x plus c. C can be any value. 1, it can be 2, it can be 3. That we call arbitrary constant. This is not directly whole constant. This is arbitrary constant. Now, this one also contains two arbitrary constant a and b. Now, in case of formation of differential equation, first you have to see how many arbitrary constants are there. If there are two arbitrary constants, you can differentiate twice. Means you can do first derivative, and you can also do the second derivative or second order derivative. Your final answer must not contain. Your final answer must not contain the arbitrary constant a and b. The final answer must not contain the arbitrary constant a and b. So see, for this one, see solution, y equal to a cos x minus b sin x. Y equal to a cos x minus b sin x. Differentiation dy dx. Dy dx will be equal to what? A sin x plus b cos x. Okay. Since two arbitrary constant, you can differentiate twice. So d2y dx square will be equal to what? Minus a, the dx of sin x is cos x, minus b sin x. Okay. Now you can take minus common, it will be a cos x plus b sin x. Now see, what is a cos x plus b sin x? A cos x your a cos x minus b sin x. So this one is first is minus a cos x. This one is here, it is wrong here. Here, correct this one. The dx of sin x is cos x. So by dx of sin x is cos x, only cos x, not a. Then again, when I differentiate this one to cos x, it will become plus. So if I take minus comma, it will be minus here. Now this will be equal to what? A cos x minus b sin x. A cos x minus b sin x is nothing but what? Y. So it becomes what? d2y dx square, d2y dx square plus y equal to 0. Now your final answer, see, your final answer does not contain any arbitrary constant a and b. So two things you have to remember. First, number of arbitrary constant. If there are two arbitrary constant, you can differentiate twice. Okay? If there are three arbitrary constant, you can differentiate third. And the final answer must not contain any arbitrary constant. Okay, understood? Next question. Say y equal to, question 2. This is question number 1. Question number 2. Y equal to a cos x, a cos log x plus b sin log x. Y equal to a cos log x plus b sin log x. Now if you differentiate this one, dy dx equal to a ddx of cos x minus sin x. ddx of cos x is what? Minus sin x, minus. So ddx of again log x, 1 by x. Plus b ddx of cos log x, ddx of log x, 1 by x. Okay? Now break this x this side. So this will be x dy dx equal to minus a sin log x minus a sin log x plus b cos log x. Again differentiate both sides with respect to x. So it will be first differentiation of second plus second dy dx into ddx of first is 1. First differentiation of second plus second dy dx into ddx of first 1. This will be what? Minus a cos log x. ddx of log x 1 by x. Plus b minus b ddx of cos x sin x minus sin x. So minus b sin log x into ddx of log x 1 by x. Multiply throughout by x. It will be x square d2y dx square plus dy dx equal to, take minus common a cos log x plus b sin log x. Take minus common. Now this will be equal to what? Implies x square d2y dx square plus dy dx, nothing but minus y. So x square d2y dx square plus dy dx plus y equal to what? Plus y equal to 0. Okay, understood? One thing I think I've done wrong here. When I cross multiply this one become x square, so this will become also x. This will be also x. So x square d2y dx square plus x dy dx plus x dy dx plus y equal to 0. Understood? So this is the preliminary concept of differential equation and formation of differential equation. Okay.